Next one is the properties of elements in periods and the groups. Okay, so first based on the valence electrons. So in a period, the number of valence electrons increases from 1 to 8 from the left to right, and the number of the shells is the same. Okay, so now they have given one example. Second period. In the second period, we are having a lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so the AN means the atomic number. So the atomic number of this 3, 4, 5, 6, 7, 8, 9, 10. Okay, so easy means electronic configuration. So here the this indicates that the 3 indicates that it's a proton number. So the proton number is equal to the electron, then it is in the atom, atomic state. So here we are having a 3 means it's having a 3 protons and the 3 electrons. So always the first shell occupies the 2 electrons. The second shell occupies the 8 electrons. The third shell occupies the 8 electrons. Okay. So now here the lithium is having the 3 electrons. So out of the 3 electrons, 2 electrons we have placed in the first shell and the 1 electron we have placed it in the second shell. So beryllium is 4. So 4 electrons are present. 2 electrons are present. 2 electrons are present in the first shell and 2 electrons are present in the second shell. Boron, the 2 electrons are present in the first shell and 3. So carbon is having a 6 electrons, so 2 electrons in the first shell and 4 electrons in the second one. 7. Nitrogen, 2 electrons are present in the first shell and 5 electrons in the second shell. Oxygen, it is 8. 2 electrons are present in the first shell and the 6 electrons are present in the outermost shell. So fluorine 9. So 2, 7. So 2 electrons are present in the first shell and the 7 electrons are present in the next shell, that is the second shell. Neon 2, 8. So if you see the neon, it is completely filled actually. So the 8 electrons has to be present in the second shell. Second shell contains the 8 electrons. So this is completely filled. That is why they are unreactive. So there is no more electrons we can able to occupy, and also there is a no need to lose any electrons. So that is why the noble gases are highly stable. Now, the valence electrons. What is mean by valence electrons? Valence means how many electrons are present in the outermost shell. So that we call it as a valence electrons. So here 1, 2, 3, 4, 5, 6, 7, 8. So the outermost shell is the second shell. So how many electrons are there that we have to place it over here? Shells. Shells are nothing but that 2, because this is the first shell and this is the second shell, this one. So 2, 2, 2. So these are all from the second period. So second period indicates that it's having only the 2 shells. So all these elements are having the 2 shells. Only the valence electrons are varying. So that gives the group, we are placed in the different groups, group 1, group 2, group 3, like that, based on the valence electrons. So in a group, so now we are going to discuss about the 1A group. So in this, we are having a hydrogen, lithium, sodium, and potassium. So AN means atomic number 1. Hydrogen is having 1 atomic number, lithium is having 3, and sodium is having 11, and potassium is having a 19. EC means electronic configuration. So this is 1 electron, right? So 1 electron will occupy in the first shell. 3 electrons are there in the lithium. So we can split that 3 electrons. The 2 electrons we have to place it in the first shell, and 1 electron we have to place it in the second shell. So 2, 1. And sodium. Sodium is having 11 electrons. So 2 electrons in the first shell, 8 electrons in the second shell because the maximum number of occupancy in the uh, second shell is 8. So 8 electrons. Once it fills the 8 electrons, next automatically we have to give the electrons in the next shell. That is 1 electron we have to give in the third shell. So potassium. So potassium is having the atomic number 19. So 2 electrons can occupy in the first shell. The 8 electrons can occupy in the second shell. Then 8 electrons in the third also we can able to fill the 8 electrons. So we are giving the 8 electrons in the third shell. So once it's completed, the next 4, the first electron is moved to the fourth shell. So if you are seeing like this, the outermost electrons are the same. 1, 1, 1, 1. So only one electron are present in all these elements. So that's why we have placed it in the 1A. So the group number always indicates that how many number of the valence electrons which is present in the outermost shell. Now next one is the shells. Okay, so this contains the one shell. This contains the 2 shell. This contains the 3 shell. 1, 2, 3, 4, 4. So the number of the shells increases in the okay. Yeah. So next one is the valency. So what is meant by the valency? Valency is nothing but how many number of electrons it can. So from we will get some idea. So how many number of the electrons the element can able to lose or the element can able to gain. So that's what we call it as a valency. So in a period, the valency of the elements increases from 1 to 4 and then decreases from 4 to 0. What is meant by that? The increases from 1 to 4 decreases. So actually the idea of this one is, so now the sodium is having a example. The sodium is having a 281. Okay, so these shells are completely filled. So we are not taken into the account. So we have to consider only the last electron which is present in the last shell. That's why we call it as a valence electrons. Valence means ability to lose or gain electron. That we call it as valence electrons. So one electron present over here. So actually the third shell can occupy 8 electrons. So we know that as we know already, the helium, neon, argon, krypton and all, they are unreactive because they are having the completely filled orbitals or electron shells. But why these elements are reactive? Sodium is highly reactive, potassium is highly reactive, and all remaining other elements in the periodic table are reactive apart from the noble gases. Why? Because they are not having the stable, complete outermost electronic shells. That is why they are reactive. So the noble gases are the one unreactive because they are completely filled orbitals. That's why they are unreactive. So now the sodium wants to attain the stable outermost configuration. That is why they are reactive. So what sodium will do now? 281. One electron in the outermost shell. So this 2 electron is present in the first shell. This 8 electrons are present in the second shell. The 1 electron is present in the third shell. So now this is completely filled. First and second are completely filled. So the third shell contains only 1 electron. So what it will do? The third shell maximum occupancy is 8 electrons. But sodium is having only 1 electron. So the easiest way only the elements will choose. So what sodium can do? It will lose the one electron. Instead of gaining the 7 electrons, it is easy to lose the 1 electron. This is the easiest way. So it will not choose the gaining of the 7 electrons. So once it loses the electron, so it becomes the 2, comma 8. So 8 electrons are there in the outermost shell. So that is a stable. That's why the sodium how sodium metal is highly reactive, because they will likely to choose, they will remove the 1 electron in the outermost shell and wants to become the stable configuration. That is very easy for the sodium to do it. So the valency of the sodium is 1. So like this, we can able to find out what is the valency of the each elements in the each period as well as the group. Suppose if the 2 electrons are present in this one, 2 electrons are present in the outermost shell, so it can able to lose the 2 electrons instead of gaining the 6 electrons. So the valency is 2. See here, now we are going to take the example of the second period. So second period contains the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. So the atomic number is 3, 4, 5, 6, 7, 8, 9, 10. So now in this case, so the electronic configuration, they have splitted into the first shell and the second shell, they have placed it. Okay. So now here the valence electron is 1 over here. So the valency is, it can lose the 1 electron. So valency is 1. Here it is having the 2 electrons in the outermost shell. So the choice is whether it has to lose the 2 electrons or it has to gain the 6 electrons. So now possibility is losing the 2 electrons. That's why the 2 electrons, it is placed over here. The valency is 2. Now the 3. So here gaining the losing the 3 electrons or gaining the 5 electrons. So again the 3 is easy compared to that of the 5. So that is why